It seems like our robot is ready and we can move to Gazebo for 3D environment simulation. And that's true. We can move forward and start adding other features to the robot. But I want to add a good practice into URDF design, and that is utilization of Xacros. That not only makes our life easy for bigger robot parts and bigger robot repeating structures, as well as more representable. So when you are working with teams, you should have everything more representable in your code, as URDF is also a code. So let's take a look how we can organize our robot parts with the help of Xacros. In our robot, there is nothing we want to change, but in our URDF file, we want to change a lot of things, and I especially want to make it more optimized and more modular. The first thing about Xacros is property. When I say Xacro, we get a lot of options, and these options are totally based on these Lewis Wutipat snippets. This plugin should be enabled, and it provides Xacro plugins. This one, Pejar, has not been able to provide us the Xacro plugins, okay, or Xacro snippets. So Xacro, it provides us a lot of things. First, you need to go through this property, name and value. What is this basically meaning? That there is a property and there is a value for it as a variable. Let me make it more understandable. I'm going to name the property to be side. The value is going to be left or front left, okay, and then I'm going to bring this property above this robot, and I am going to say here that this is going to have this property being utilized. How? I am going to copy it, then I'm going to say utilize the property like this. What it is going to do, it is going to replace the side with this value. So it's sort of variables that we want to utilize in this code. And how does it makes it modular? You can see I am going to copy this whole one, and I'm going to replace here as well, and I am going to also get this and put it here. When I want to make changes, I am just going to rename this thing, and it is going to be automatically being updated. I'm going to say rear wheel, rear left, right left, whatever I want. But the thing is, I don't have to change things on all of these 3 to 4 places. That makes a lot of things easier for us. To run this, you need to make some changes in the URDF as well. The first one is to include this Xacro tag as well. And with the help of this plugin, you can directly add it, this Xacro robot. It basically brings in this XMLNS, and it asks for the robot. We delete this ending tag because it is present at the end here, and from our URDF perspective, things are now working. Things are complete. Let's move to the launch file. For the launch file, we have to make some changes. While loading the URDF file, we need to get the URDF file as a command, because I am going to say use Xacro to process this file, and this file is also going to be a urdf.xacro now, and I have to make changes here as well, as it contains the Xacro tags. So it is going to be rover.urdf.xacro. That's how it is going to be, and I have to put these single commas around this whole file to find and put it as an input to Xacro. If you don't have Xacro, you can install it with the sudo apt get install ROS NOETIC Xacro command. So now let's run it and see how does it looks like. You can see the simulation has come up successfully, and if I see we have the wheel front left joint, let's make some changes so we can actually compare it with the previous thing. If I change the name here, I say big, just to make some difference, and let's see if I get any difference. This tag, this wheel big joint, You can see it is working, but the name has been changed. And the most interesting part, if I go back there, I just changed the value here and it got applied on 3 different places. This was property. In most of the robot descriptions, these properties are very useful. It can be a lot of things. For example, I could say pi and I would provide the 3.14 value to it. It can be like constant that hold the values, string the values as floats and all that stuff. It can store a lot of values, as we have a lot of examples here in the using Xacro to clean up URDF file. Like we can utilize mathematical equations as well. You can see wheel diameter divided by 2 and length by 0.1. So you can utilize in this manner as well. The next thing is a Xacro macros. They sound to be confusing, but they are going to be really useful. Let me show you. So if I create a Xacro and I say I want to create a macro out of it, that is going to help me create blocks of code, and I can call that block again and again with the same properties. In our scenario, one code is repeating again, and that is of wheels. There is only the change in the name, but all other properties are totally the same except this origin. So what do we want to do? We don't want to copy and paste it again and again. We can create one block and call it again and again with just 2 lines. So that makes our code very small. Let's take a look. So I am going to say that my macro is going to be wheel. There is going to be name. There is also going to be x, y, z, which is going to be this x, y, and z. All other things are going to be the same, I guess. So I am going to copy it, from this point to this point, this whole link for the wheel, and I'm going to bring it here. Let me indent it properly. So before making any changes and making the use of macros, you need to understand one thing. I am going to be providing the values for these x, y, z and name. These parameters are actually similar to properties, exactly the same, but I have to provide values to it. When I will be calling it, I will add the values. That is going to make sense. But for now, I am going to say that whenever you have this thing, wheel front right, I am going to replace it with $name and make sure the brackets are proper. Replace it here, replace it here, replace it here. So at this specific point in this macro, you can see this parameter name or the property is going to be whatever the value I assign is going to be placed here, and it is also applied on these 2 other lines. The next thing is this XYZ. So I have to give the values here with the $x, and the brackets should be exactly the same. They should be these curly brackets. Let me copy those brackets, x, then for the second one y, and I don't think so we have the z element for the wheels right now, and that's it. We don't need any other thing in our wheel to be changed, so we'll keep it that way. We just need to change the name, x and y. Interesting thing is this structure is repeated again and again, right? So I am going to now call this structure, and how we can call it? It is going to be done in the same fashion like Xacro, and the name of the macro that we have defined should not get confused in the Xacro and the macro. Macro is a block, Xacro is the style. Okay, Xacro wheel, because we have defined this macro name to be wheel, starts here and it ends here. That's how it starts and ends. The block is defined here. I just need to provide the names of the parameter. The first thing is name. Yes, name is fine. Name is equal to something, then x is equal to something, and then y is equal to something. This name is different from this name. It's this parameter, this name, and I am going to say name to be rear right, and then in the rear right joint we have 0.25 and 40. X is 0.25 and 0.40. These are the 2 things that we have here, and just with this line of code I am actually calling this whole code, and all the values are going to be set. It is really interesting. So the next thing is we just reduce it to one single line like this. So as our macro is ready and we have called it once for rear right, let's replace the rear right wheel with it. There's one mistake in this macro. I'm going to crop it, and I have deleted the property, so I am going to remove it as well because the property does not exist. So where was the right wheel? Rear right wheel. This was the rear right wheel. I am going to remove it. I'm going to replace it with the macro and the call of the macro. Although the above code from this is just to define the macros, the below code is just going to create wheel. And we do not have to repeat it again and again. We are going to create rear right and it's going to perform all of the things. Let's see if it works. And yes, the problem that I was talking about, this has been a mistake. I have provided a wrong bracket, so I'm going to replace it, and now it is going to work. And you can see all of the wheels are there and they are working. Let me show you the actual magic of Xacros. Now as our simulation is working, we need to add other wheels. Let me copy paste rear right and front right, front left and then rear left. In here I have to change the x y values accordingly. Rear right, it's fine. Front right, but we have rear left values first. They are minus 2.5 and negative . Now we have interesting part. I have to remove all of these, and that's our new code. Let's see if it is working or not. You can see all of our wheels are there. Our code has reduced. The transforms are working for all of these, and our URDF file has reduced to, I think, from 180 to only 85 lines, and that's it. That's how simple things become when you use Xacros with macros. So our robot is inside of Gazebo and it has passed ROS. The next step is to think about optimization. You might be curious that I have seen good robots in the simulation. Our robot is just made up of shapes and that does not make any sense. So now let's see how companies build their robots in actual real world and also utilize that 3D model, the 3D structure of that robot inside of ROS as well, bringing the STL or other 3D mesh files into Gazebo and ROS with colors. We created our robot with general shapes like cylinder and box. That's how we created it, right? If we want to create something more useful, something from a 3D model or a practical approach is basically using a designed robot structure. How we do that? We can add it into our geometry and collision tag. So let's get some models from the internet, and I will be getting model from Turtlebot 3. And to obtain the 3D models, we are going to get Turtlebot 3 wheels and fix it with our robot. It is going to be description. Robot is get Turtlebot 3, and in ROS, whenever you want to take a look into the 3D meshes of a robot or in a package, you have to go through this directory which represents the robot. Meshes are there and URDF files are there. Description. So Turtlebot 3 description. In that we have meshes, and here I'm going to go inside wheels, left and right tire. You can click upon it and download it. I already have that in my ROS1 wiki mobile URDF, or I can create another directory named as meshes and I can obtain these 3D models and put it inside of meshes. Okay, here I am going to select it and remove it in the geometry tag of the visual, and I am going to say that I want to add a mesh, and we have something like simple mesh, mesh and geometry mesh. I'm going to press enter and it automatically adds the geometry tag which we don't need, so we have to use the simple one, mesh. File name and scale. File name is going to be little confusing because the syntax is different from $find package. So it is going to be like package mobile robot, then the meshes folder, and then left_tire.stl. that is the path, left_tire.stl. you can see they are not apparent inside of my URDF preview, but they might be apparent inside of ROS. Let's test ROS launch mobile robot ROS. There is a problem. Mesh scale was specified but could not parse. I think the problem is related to only one axis is defined. If I want to represent it in 3D space, it has to be for 3 axes. I have to remove in the collision tag as well for the future need, but not for ROS collision properties to be generated. If I look at this picture, I would say the wheels are not there, but the wheels are there, but their size is so big. You can see whole robot is very small for it. I'm going to fix that problem by using this scale factor, and it's an arbitrary number. Now the wheels are present here as well. We can use the URDF preview to fix this scale problem very easily. 0.01, let's see, 0.01, 0.0, save it, and they become really small, but still they are little bigger. If I make it 0.5, now it seems to be more appropriate. The next thing I should do is remove this rotation that I gave for the other wheels I had. Copy this, and I'm going to add for the collision as well. Press save, and you can see Turtlebot wheels are now applied, although there is a problem that these wheels are for the left tire, and for the other two there should be the right tire should be applied. And if I want to visualize it inside of ROS, I can run the same URDF. You can see here a right wheel should be applied, but I'm not going to do it. I leave it for you. It's very simple, just apply different name. So that was adding an STL or 3D meshes into your robot, and it's generic because it finds the tires through your package, then meshes, then STL files. So the next step should be 3D environment simulation. We need to understand the difference between gazebo and ROS. ROS is what the robot is actually seeing. Gazebo is the whole world. It's outside of the robot. ROS is inside of the robot. What the sensors are saying, ROS tells us. What the world is interacting, gazebo tells us about that. Now in gazebo we have two requirements. We need to have collision properties, we need to have inertial properties. These two are not required in ROS because in gazebo we have 3-dimensional environment which deals with physics. Graphical engines are there, so we need to take care of these things. The very first thing we need to do is to create another launch file, and that launch file is going to be gazebo.launch file. We don't need ROS for that, and I am going to remove ROS GUI. One node that we need to add is gazebo ROS node, and its type is going to be different. Package is gazebo ROS, type is spawn model. That spawns the model into our simulation, but the simulation is not there right now. Spawning URDF. Here we are going to write include, and it is going to be including from gazebo ROS. You are going to go inside of launch and empty world dot launch, and it is not going to end here. We are going to add some arguments which are essential, and it is going to end at this point. So what it contains, gazebo ROS and empty world.launch is a launch file that contains these arguments. It is not going to be paused, sim time is going to be utilized, GUI is going to be there, world is turtlebot 3 gazebo empty world as a world name. If I just uncomment this argument, I think an empty world is going to be executed. Coming to the arguments are going to be really interesting. First, it is going to spawn the model by naming it to be rover. Then the parameters that we want to add are robot description, which contains the robot description as a URDF file converted from Xacro. Before running, I have to add one last argument, and that is minus URDF, that this is going to be, this robot description contains a URDF. The model is actually a URDF. So now let's run this gazebo.launch file. There might be some error because of one thing, and that thing is we don't have the model here, and the reason is we don't have initial properties for the model. That's why the model does not appear. Although the error is not printed here, there is no such error. Okay, in Gazebo we deal with the physical properties very seriously, as mass value is 0. If I change the mass value to 1 for the wheels, and I think not 1 would be too much, 0.5 for each wheel, and the base mass value is going to be 1.0. Mass value has been provided, inertial values are still not here. I go here and run this again, gazebo.launch. Now you can see we have a robot in the simulation, but we don't have inertial values. Still a robot is inside of simulation. The point here is there are no colors for this robot, and for colors you need to define explicitly for Gazebo. We provided colors for ROS, but for Gazebo we have to provide other tags for colors. The problem is still there. Left wheels are fine, but on the right side the right wheel should be added, and left wheel is utilized. So the next thing is important one. Gazebo simulation is working, but our inertial values are still 0, 0, 0, 0. If I go into the ROS wiki tutorial, there is a proper tutorial, physical and collision properties to a URDF, how you can add it. If you go there, there are a lot of theory provided us inside of the inertial tag, and you can go through it a lot. This MUKP KD contact coefficients are really helpful if you want to increase the friction of the wheels. In inertial tag it says it's a 6 3x3 matrix that contains 6 elements, that is rotational inertial matrix. So what we have to do, we have to fill these values according to the shape we have, list of moment of inertia tensors. That's what is important to understand if you are making your own robot. You might have seen that I have copied the provided inertia. You cannot utilize same inertia values for every single thing. Let me just paste inertia values and I'll just show you. Okay, for the wheels let it stay 0. For the base let's provide this inertial value. If I run this simulation and I perform view inertias, you can see a big box has been created around the robot. And what it should have been done, this whole big box should be only around the base. So this big box is not a proper inertial value for the robot. Okay, we have to find exactly appropriate value for the inertias. If we go to our moment of inertia and we go to the solid cube through which we have created our base or similar shape, you see it says that this is the formula you need to apply. What are the requirements? Width and height and the depth. In our scenario, I think the width is the x-axis, height is the z-axis, and depth is the y-axis. That's how the cube has been created. We have the values for these things and we have to plug in these values here. Ixx, Iyy, Izz values are then calculated and they are written here. If I simplify it, I will bring these things like this. Ixx, Iyy, Izz, all other things are 0 according to this Wikipedia page, and that works basically. So if I want to move forward, the first thing I would do will be creating Xacro properties, because I have to write these equations inside of this code. So Xacro property inline. What is the property? I would say mass. Then comes another property that is mass, width and height. Mass, width, height. What are the other things? Mass, width and height. And then comes the depth. And I think I have one more value, that is constant. All of these contain proper values which are going to be utilized in the equation. Constant is 1/12. According to the equation, 1/12 multiplied by m. I would say the mass is 1.0. Then h square plus, for our scenario, height is 0.1 and depth is going to be 0.7. Width is going to be 0.8. I just want to show you how you can utilize this properties in an equation and utilize it for your robot. The next part is going to be writing the equation. So you can understand that in this specific manner. Start the bracket and you directly write the equation here. For example, if I want to write this equation, mh square plus d square, it is ixx. How do I know that it's ixx? If I take a look here in the inertial matrix, this is ixx, iyy and izz in the diagonal. And in the diagonal, these are the formulas. So 1 by 12 constant multiplied by the mass, it is going to be constant multiplied by the mass, and then the bracket starts. Simply write the equations direct in this fashion. H square and d square. So I'm going to say h square plus depth square. That's how this whole equation is going to be written, and you have to write for iyy and izz. It is going to be computed. You don't need to write the numbers directly. It is going to cause a lot of problem. You just change the values here and all of the values are going to be implemented in ixx, iyy, izz. That's the easiness of this Xacro inline properties. I will leave you here with the task for you to complete it and run it and make it work on your gazebo simulation. If you are still watching the video till this point, you have gone through good examples of URDF and Xacros and Meshes. Now it's time to take a look into actual real world commercial robots like the Husky, ClearPath and Panda robot, how they have built their URDF, so you can get better understanding of URDF robot construction. And interestingly, you are capable enough now. I have opened up 3 repositories for different robots: Hector quadrotor robot, Franca ROS robot, which is a robotic arm, and then Husky, a mobile robot. So if we go into all of these repositories, we will see one common thing, that is this Hector quadrotor description directory. There are other common things as well, gazebo, plugins, controllers, but description directory, description package contains the URDF and the meshes. You can see we have meshes here and a URDF file as well. Coming to the next one, we have Franca description, we have meshes, but we don't have the URDF here, and here it is, Panda URDF Xacro. If I go into the Husky, description, meshes and URDF, there is a launch file as well, but URDF contains all of the parts combination for the robot. So if I say quadrotor, it's a Xacro file, gazebo Xacro file. So you can see it contains a lot of Xacro files. Where it is, quadrotor base urdf.xacro. If we take a look here in the quadrotor, you can see first Xacro robot is initialized, then Xacro file name, another file has been added, then there is a property, the pi value has been saved, then comes a macro. What does a macro does? Macro is a block that is utilized again and again. So Hector quadrotor contains a base link and the visual collision and inertial properties for that specifically. Then it calls another macro, which is sonar sensor. I don't know where it is created. I think so in this Xacro file it would have been created. It is called, and you can see a lot of parameters are passed. Now we have to take a look into it. How does it cause it? It is present inside of Hector sensor description. So Hector quadrotor, Hector, let's go into the description. I think so we cannot find it here. Hector sensor package has to be found. Anyways, I don't think so the sensor package is here, or I might not be able to find it. The next thing is meshes. What are the 2 meshes? There is a quadrotor base, which is a DAE file. It's not these programming lines, it's actually 3D file. Coming to our Panda robot, Franca robot.xacro, that is included as a file. Let's take a look. Franca robot.xacro, what does it contains? What was the path? Franca description robot common, Franca description robots, and then common, then Franca robot.xacro. I think it's a big Xacro file. Okay, a lot of things are there. It's basically a macro gazebo joint that is called, and this is the name of the parameters, or you can say properties, and there's a transmission property. You can understand it by going into the macro for this specific file. There are a lot of things that you are able to understand what they are written. What is this macro doing? What is this property doing? What is this argument, include file? All of these are interesting. New things are also there, like if conditions applied that we have not done, but you can go through it, you can understand a lot of things. You don't need to look into this thing that has nothing to do with Xacro. It's basically a plugin. So that's why I wanted you to take a look into the code of commercial robots and understand how their URDF has been written. These transformations has to do with ROS control, nothing to do with Xacros. Okay, we'll understand it in the upcoming lectures. So let's sum this up. You know how to make a simple URDF robot, then you can add Xacros, then you can add 3D models into your robot to make it more aesthetically good, not just built from the shapes, and you understand how commercial robots are built used in the simulation. The next step that you should be taking is adding sensors, and obviously I will explain how you can utilize the sensors provided by Github and see the results in ROS. Till then, take care.